Today we will have a quick insight of regression analysis. So we know that there are various types of the models are discussed in the literature. So we will focus about the simple linear regression analysis, and multiple linear regression. As we know that there is a equation which is called equation of line. We must have cleared the 10th standard. In a 10th standard, whether it is a basic or standard, you must have studied the equation. That is nothing but equation of a line. So what we write the equation of line, y is equal to mx plus c, where c is said to be intercept and m is said to be a slope of the line. And that is when you make the graph on a graph paper, in the x-axis you are keeping x, in y-axis you are keeping y, which is nothing but the line which is known as y is equal to mx plus c, and this is said to be a c, that is nothing but the intercept. Now, if you wish, we in a different notation, we can write this model as y equal to beta 0 plus beta 1 x, where c is beta 0 and m is beta 1. That means beta 0 is the intercept parameter and beta 1 is said to be a slope parameter. Again, if you know the value of beta 0 and beta 1, given a value of x, you can obtain exact value of y. That is what the equation of line is saying. If you know the value of beta 0 and beta 1, given a value of x, you can exactly obtain the value of y. But we statisticians differ slightly with the mathematical model. This is called the mathematical model, and we have already seen the Kant's model. So Kant saying that, let us say it is a consumption expenditure and x is said to be an income. So as we know that Kant's theory is saying that as the income is increasing, the corresponding consumption expenditure is also increasing, and it is saying that the relation between x and y is linear in nature, logically. Now, beta 1 is nothing but the regression coefficient, or it is a coefficient. As per the mathematical model, the mathematician has given the Kant's theory into this form. So as the x is increased, corresponding y is increased by beta 1. So beta 1 is nothing but it is known as the elasticity coefficient. It is saying that the unit of change is observed in the x, corresponding change is observed in the y by beta 1. If beta 1 is positive, y will have an increased value. If beta 1 is negative, as x is increased, y is decreasing. So the sign of the coefficient matter a lot. Now if we go ahead, do you say that the consumption is a purely function of income? No. There are so many other variables which are also affecting the personal consumption of a family. Income, then size of the family, how many members are living in the family, what is the size of the house. If you are saying that the electricity consumption, if you are developing the model of electricity consumption with the income, so as we know that as the income is increasing, electricity consumption is increasing. Is it? Not necessary, but it is saying that possibility is there. Why? Because as the income increasing, your house size is increasing, number of members are also more, and therefore the gadgets are also more, and that is how the electricity consumption can increase. Another example, if you can say the cells of a car, which is a function of a several variable. So let us say y is nothing but cells, and x. So here y is said to be a dependent variable, x said to be a independent variable, because x is in our control, y is not in our control. So we are trying to see that what kind of the changes we make in the x so that we can have a corresponding change is observed in the y. So if I wish to develop a model of the cells of a car, what would you say that what are the factors which can help to improve the cells of a car? So suppose we, rather than the industrialist, as the industrialist we think like a customer. Suppose if I wish to buy a car, what we see in the car? So what are the variables according to you?
Price, mileage, color.
So let us say price of the car, then mileage, safety,
Number of seats.
Color.
Number of seats.
look,
Number of seats.
size, small or big car, then variant, whether it is a CNG, whether it is a diesel, whether it is a electric, whether it is a petrol, then
Company.
brand,
Color.
resale value, color, it means let us say aesthetic, which is including about the design, color, then boot space, if you are talking about the the boot space, ground clearance, features. So these are the, you can add, let us add the features. So it means that there are so many variables which are affecting the cells of a car. Now my question is that how do you know about the car? So advertisement. So individual has to have also advertisement, but advertisement, so of course one has to have a expenditure on the advertisement. Now my objective is that the cells of a car, which is a function of advertisement expenditure. So if you ask the mathematician, they say that, sir, let us say you have a one dependent variable, one is independent variable. So what is the impact of the advertisement expenditure on a cells that you wish to study? So you can have this model. But do you say that the only advertisement is responsible for the cells of a car? No. Because there are so many factors you have said. So like if I am saying this factor says x1, x2, x3, likewise, so many. So I am considering only the cells with a function of a advertisement expenditure. Then what happened? What about the other variables which are affecting the cells of a car, which you are not considering? So what we keep them as a epsilon term. When we say that epsilon is nothing but it is a cumulative effect of all other variables which are affecting the my cells of a car, but I have not considered in my model. So I will write epsilon is nothing but cumulative effect of this whole variable which I have not considered in my study. So now when you are saying that, when you are looking for a cumulative effect, then what we have to do? Because I wish to minimize this, because I am interested to tell what is the best impact of the advertisement expenditure on a sales. So I have to minimize it. So we know that the sales is a function of advertisement expenditure, but there are so many other factors which are affecting the sales which we have not considered. So we will write them as a epsilon, and epsilon is nothing but the cumulative effect of all other factors which are affecting the sales, but I have not considered in my study. So now what is my aim? I wish to see that what is the best impact of the advertisement expenditure on the sales. So that means I have to minimize this part. So in regression analysis, if you have a one dependent and one independent variable and the relation between y and x is linear in parameters, then we call them as a simple linear regression model. Now, before going to regression analysis, we have to always look for the logical relationship between the y and x. In our setup, it is saying that the sales of a car and advertisement expenditure. So since it is a reasonable that as the individual having a more spending on advertisement expenditure, the corresponding sales will also be increased. So it is showing that there is a logical relationship. Now, whether the logical relationship is a linear or not, so how will you identify? You are making the scatter plot. So you can have a record of a advertisement expenditure as well as the corresponding sales, and if you make the point and if the graph is like that, it is showing that there is a linear relationship between the x and y. Even the sign of the regression coefficient you can also decide based on the plot. This is saying that as the x is increasing, therefore the y is also increasing. It seems that the sign of the regression coefficient is positive. Otherwise, if it is a reverse, it is a decreasing. So that rough idea from this, and whenever you have an estimated model, you can verify whether the whatever the estimates we are getting and the data are actually in the same direction or not. Now, in regression model, we call them as a systematic part. So this is called systematic. Systematic why? Because if you know the value of beta 0 and beta 1, given x, you can find out the value of y. And this part is said to be a random part. Now when you say the random, because x is a fix, when you are developing the regression models, so it is nothing but you are finding the expected value of y or average value of y conditioning on x. So you are making x as a fix. Otherwise there is a joint bivariate normal distribution between y and x. But when we are talking about the regression, we are having condition on x. So we always look for the assumption on the y. But what is the distribution of y? It depends on the distribution of a error term. And what is the distribution of error term we are considering? We are saying that epsilon is normally independent with mean 0 and variance sigma epsilon square. In econometrics, we use the disturbance rather than the epsilon. So you must have studied it is a sigma u square. U is distributed as a normal, I for independent with mean 0 and sigma u square. Now when you say that the epsilon, so how many observations you are considering? An observation. So you can have a y1, y2, yn observation. Corresponding you can have a value of x, that is the n values of x, and you can have a corresponding epsilon 1, epsilon 2, epsilon n. So we say that epsilon I is normally distributed with mean 0 and variance this is a now what it's saying that what is the meaning of this? When you have an assumption of epsilon, many times what happens when we do the regression analysis, we will verify कि y has a normal distribution or not, whether the variance of y is a constant or not. Actually, the assumption are on epsilon, and epsilon is said to be error, which is unknown to us. So what we do? We obtain the estimate of it. Error. It is called residual. It is nothing but observed value of y minus predicted value of y. And then you are making the assumption on verifying assumption on a residual. So many times what happens when you are developing the models, your y does not follow the normality, don't worry. Because assumption is not on y, assumption is on a epsilon. And epsilon is unknown, so you have to find out the estimate of the epsilon, it is called the residual. And then verify the assumption whether the model is adequate to the data or not. Now, how will you find out the yi? So you say that because of I wish to minimize this quantity, so so that I can have best impact of x on a y. So when you are saying that minimizing the error, it is as good as the, if error is small, then that square is also small. So when you are making the sum of the square of error, you are trying to minimize that. And that is how when you say the minimizing, it means least. And because you are minimizing the square, so it is called least square. It is minimization of error, so it is the least square error. So that is how we can have to apply the OLS method, that is ordinary least square method, to minimize the sum of square due to error, so that we can have an estimate of a beta 0 and beta 1. So here beta 0 estimate is a beta 0 cap, and beta 1 cap is a beta 1 estimate is a beta 1 cap. So you can have a y0 ya cap equal to beta 0 cap minus beta 1 cap xi plus. So what is the beta 1 cap? So we know that beta 1 cap is nothing but the covariance between Sxy and variance of x, that is Sxx or Sx square, and beta 0 is nothing but it is a y bar minus beta 1 cap x. So now you can have this epsilon I. Now once you have this epsilon I, you have to see whether epsilon I are independent or not. So how will you verify whether the epsilons are independent or not, or the residuals are independent or not? So we know the test which is called runs test. So independent assumption will be verified by the runs test. Okay, and because it is a formal test, what will you and how you are assessing this? By a run test. So you can have assumption that data is independent of order. Sometimes it is said to be data is not serially correlated. So these are the different nomenclatures the in a literature author have used. Now run test, you are having a value, p value, and if you are comparing the p value is less than or equal to 0.05, we say reject F naught. What is the F naught? Data is independent of order. And when you reject, it means data is not independent of order. It means data is serially correlated. It means that you are violating this assumption. So run test should accept the hypothesis. Then you say that the data is independent of order. So we have to accept it when p value greater than 0.05. Now why 0.05? We call them as a level of significance. Ki how much percentage of errors we would like to allow in our decision. So we say 5%. So with 95% confidence we are saying that our null hypothesis is accepted or rejected. Once it is clear that residuals are independent of order based on the run test, now what is the another assumption you can observe here? It is a normally distributed. So how will you verify whether the residuals are normal or not? Using the either Shapiro-Wilks normality test or Kolmogorov-Swindle test. If you are using the SPSS, they must have given the Shapiro-Wilks normality as well as the Kolmogorov-Swindle test. If you are going for the R, it has given the Shapiro-Wilks normality test. If you are going for a mini tape, they have given the Anderson-Darling test. There is a test called the Jerk-Bera. So there are several tests are available. You can use any one of them to verify this assumption. Now, what is the null hypothesis in the Shapiro-Wilks or the Kolmogorov-Swindle test? Data is coming from normal distribution. Now, if the hypothesis is accepted, it means data is normally distributed. If rejected, data is not normally distributed. How will you verify? To look at the p-value corresponding to the test, whichever you have selected. If it is greater than 0.05, accept it, otherwise reject it. So once you have a data is a normally distributed, data is independent of order. Now third assumption, you say that epsilon is having a constant variance. So how will you verify whether the epsilon is unknown, so your estimate is residual. So how will you verify the residual has a constant variance or not? So there are the several tests of heteroscedasticity are there, but that we will see later. But graphically you can verify, you have to make the plot of residual versus yi cap or residual versus xi cap, xi. If there is no pattern, it is the scatter, then we say that the residuals are independent of the yi cap, or yi cap itself is a function of xi. So residuals is a free from x, and that is how in a regression we say that x and epsilons are independently distributed. So that you can verify from this. Another way of normality you can verify using the histogram graphically. If the histogram is like symmetry, and if you make the bell-shaped curve on that, then you say that data is normally distributed. You can make the box plot. If the box, it is also known as the box and whisker plot, and if it is a symmetry, this is said to be Q1, this is Q2, this is Q3. Q1 is nothing but the first quartile, Q2 is the second quartile, and Q3 is the third quartile. And if Q3 minus Q2 is equal to Q2 minus Q1, then we say that the box is divided in two parts. It means the data is coming from a symmetric distribution. Third one, you can verify the normal probability plot. It is a PI, that is the probability of the, or it is a percentile or the quantile, and EI is nothing but the your residuals which are in a ascending orders. And if you make the plot, and if you are making the normal probability line, if all the point is covered by this line, then we say that the data is coming from a normal distribution. So these are the graphically. By test you can have verify using the Shapiro normality test, Kolmogorov-Monro test, Jerk-Bera test, Anderson-Darling test. You can use any one. So now all the assumptions are true. Now what happened? We can go for the goodness of fit of the model. However, this assumption usually we will verify when we go for the testing whether the model is adequate to data or not. So first our objective is that we will estimate. So this is the estimate the model. Yi cap equal to beta 0 cap plus beta 1 cap xi. It is nothing but the estimated model. Now, once you have estimated model in your hand, you wish to verify whether really x is important to explain the r or not, or y or not. So you can apply the goodness of fit criteria. What are the goodness of fit criteria we have seen? So first is a r square. Second one is adjusted r square. Third one is AIC. Fourth one is BIC. Fifth one is velocity. And sixth is a forecast chi-square. However, this is forecast chi-square having a weak test, so usually we will focus on these are the 5. Now what is the r square? R square is nothing but it is a square of multiple correlation coefficient. It is also known as a coefficient of determination. It is also explaining that the percentage of total variance of y explained by the regression. If you have more than one regression, then we call it as a regression. Okay. Right now we are talking about simple linear, so we will go with that. R square is usually defined by sum of square root to regression divided by the sum of square root to total, or in econometrics we sometimes use as explain sum of square divided by the total sum of square. If what is the range of r square? It is said to be, it is lies between 0 to 1. Higher the r square, better the model. It means whatever the regression you have considered in the model, which is really useful to explain the value of y. Now r square is said to be a in-sample criteria. Why? Because if you have a 100 observation, so from 100 you have randomly taken either 70% observation or 80% observation for the model development, and rest of the observation you can go for a prediction purpose. you predict it and you verify whether the prediction error is less, it is saying that ki whatever the models you have developed, it is considered to be good and it can be used for the future purpose. But it does not talk about the out of sample. If you have a 101 sample is there, information of a respondent, then we can't say that we can use the particularly this model or not based on that, because it does not give any guarantee about the out of sample forecasting criteria. But what is the problem with the R square? R square always increase. If you add one more variable, sir, we will add the price. Then what happens? You have advertisement expenditure, you can have a price, then R square say we always increase. Whether the price is really important for the model development or not, R square doesn't take care of this. So this is a problem with the R square, and hence we need to add the extra penalty of adding of a variable. We can call them as a adjusted R square. Now adjusted R square is not necessary that it is always increase. If the added variable is really important, then it will increase the adjusted R square. Now again, adjusted R square is also in simple forecasting criteria. So that is how we have to look for the another criteria which is also good for the out of sample forecasting criteria. So we can go with the AIC, the full form is Key Information Criteria, which is useful for the large sample type, the large sample size, or how you are taking the decision. If you have a two models for a comparison, lower the AIC, better the model. Another simple goodness of fit criteria is called the DIC, that is called Bayesian Information Criteria. What is the Bayesian Information Criteria? It is useful for the small sample. It is also known as a squash information criteria. Again, AIC has the harsher penalty than the adjusted R square, and BIC has a some more harsher penalty than the AIC. But AIC is useful for a large sample. Even your model is of a non-nested in nature, still you can use the AIC. That is not true for the R square as well as the adjusted R square. AIC, BIC can be also useful for a non-nested comparison of the model. Then you can have a malocity statistics. So as we know that if you have a several regressions are there, and if you wish to compare which model is suitable, so you have to look for the malocity statistics, lower the CP value, better the model, but the CP value should be closer to the P. P is the number of regression which you have considered in the model. So in that way you can select. Now once you identify that the sales is a function of advertisement, R square is high, adjusted R square is high, then we can proceed for this model. Now these are all the goodness of fit criteria. It is simply saying how these regressions are important. It does not give any guarantee, and for the guarantee purpose we always go for a testing of hypothesis. So estimation part we have done over here. Now whether this estimated value are really representative for a population or not, because we wish to generalize. When we are going for the testing, it means that whatever the sample information we have, are we in that position to generalize for a population from where the data is taken? If we wish to generalize, we have to go for a testing of the hypothesis. So what are the hypotheses are you going to test? So you are saying that, sir, how many parameters we have considered here? Two parameters, beta 0 and beta 1. So if I am writing this two parameter as beta, it is a beta 0 and beta 1 is equal to 0. It means beta 0 is 0 and beta 1 is also 0. Now what is the versus? Alternative. Because whenever we are writing the null, we can have always a alternative. So versus H1 we say that at least one beta j, at least one beta j not equal to 0, where j equal to 0 and 1. It means at least one beta j not equal to 0. It means it may possible either beta j is not 0 or beta 1 is not 0 or both are not 0. Because if both are 0, then null hypothesis is already saying that both are 0. The worst is that at least one of them is significantly different from 0. Now how will you go for the simultaneous testing of this regression parameters? So one has to go with the F test. So what the F statistics saying that you find out the sum of curve due to regression divided by the corresponding degree of freedom. Here we have a 2 parameters, but beta 0 cap is a function of beta 1 cap. Okay, so it means that we have only 1 degree of freedom corresponding to that. And sum of square due to error, how many n observations are there? So degree of freedom of total parameters are 2, observations are n, so n minus 2 is a degree of freedom. And this has a f with 1n, n minus 2. Compare the calculated value of f with tabulated value of f with 1 and n minus 2 degree of freedom. If this is the case, reject it. Or otherwise, many softwares are giving the p-value. Look at the p-value corresponding to f test, and if it is less than alpha if you have considered the 0.05, reject it. Less than or equal to reject it, otherwise accept. Now if the null hypothesis is rejected, now what is the interpretation of that? It is saying that both are not simultaneously 0. Both are not simultaneously 0, so you can go with this model. Now when both are not simultaneously 0, so now the question is that, is there any one of them is 0? Or both are different from 0? So for that we need to go for a individual testing of parameters. We require the individual testing of parameters, that is beta j equal to 0 versus beta j not equal to 0, j equal to 0 and 1. And which test is t-test. And now what is the test statistics for a t-test? It is nothing but the estimate of the parameters minus value under h0. But under h0 value is 0. So beta j cap minus 0, you can write beta j cap divided by the standard error of beta j cap. And because t is a symmetric distribution, it may be positive, it may be negative. So we always compare, and it has how many degree of freedom? Here error degree of freedom is n minus 2. So t has also degree of freedom is n minus 2. So we take the absolute value of this, compare the absolute t calculated with t alpha n minus 2. If this is the case, reject it. It means the beta j is significantly different from 0. Now if j equal to 0 and if the hypothesis is rejected, it means beta 0 is different from 0. It means we have to keep the beta 0 in the model. When we verify the beta 1 and if it is also different from 0, it means the model containing the parameters beta 0 cap and beta 1 cap. Now this is the final models. Already you have discussed the residual analysis, verify the all assumptions. If all assumptions are true, then we can use this model for the prediction purpose. And given a value of advertisement expenditure, what will be the sales of a 2026 if you have collected the data up to the sales of a 2025? So that you can predict. And why we need to go for a prediction? Because of the measurement of a planning. Whenever we are going for prediction, our purpose is planning. If predicted estimated value with a good accuracy in our hand, we can plan better. But now the scenario is that, sir, beta 0 is null hypothesis. When we are doing this, it is accepted. It means beta 0 is 0, but beta 1 is not. It means the model is without intercept. So many times the question is that whether the model is without intercept or not. So you can verify this. But when you are saying about the sales data, can you say that the model should be without intercept? No. Why? Because if you are not spending a single rupees on advertisement, still there is a sales. So logically you have to verify. Though it is a insignificant, but the scenario is saying that intercept is always there. So we have to keep intercept in the model. We should not be rigid, no, it is p-value is less than or greater than 0.05. it is not significant, just throw away. We have to logically also verify simultaneously. Now if you say that no sir, I wish to develop the models based on this all the variables. And when you wish to develop the models based on this all variable, it means that how many regressions you have? More than one. Then you can apply the concept of a multiple linear regression. So what are the assumptions again in the multiple linear regression? The same. Y equal to model is defined as beta 0, here beta 0, beta 1, x1 plus beta 2, x2 plus up to let us say I have a k regression, beta k xk plus epsilon. So what are the assumptions? This epsilon is normally independent, which means 0 sigma square. Another assumption is that normally independent. Other assumption is that this x1, x2, xk are independent, and further this x1, x2, xk are also independent with this epsilon. So these are the assumptions are there. So it is easy to deal with this model in the matrix notation. So we can write this particular model in a matrix notation as a y equal to x beta plus epsilon. In econometrics we consider the disturbance. Here in regression we are using epsilon. Now what is our basic idea? Here we say that epsilon is n variate normal which means 0 and sigma epsilon square ideal. It means epsilon 1 has a mean 0, variance is sigma square. Epsilon 2 has a mean 0, variance sigma, because identity all diagonal values are 1. So it is saying that epsilon having a constant variance. And what about off diagonal? It is 0. So it is saying that epsilons are independently distributed. So which we have taken earlier assumption, epsilon i's are independent, normally independent with mean 0 and sigma square. So that in matrix notation you can write it this way. Further here it is saying that rank of x is full. Suppose it has a p, so p is equal to, you have taken the p equal to k plus 1. So you say that the rank of x is a full rank matrix, and if it is a full rank, then x dash x is invertible, and when it is invertible, the least square estimate of beta is x dash x inverse x dash 1. In this model, beta 1, beta 2, beta k are said to be a partial regression coefficient. Why partial? Because if I wish to study the impact of advertisement expenditure by controlling other variables, so I am looking the partial impact of advertisement expenditure on the cells. So that's why the regression coefficients are known as a partial regression coefficient. This is where you have obtained the least square estimate. So once you have this least square estimate, what is the estimate of y? It is whenever the beta, just substitute them x beta k. What is the residual? The residual vector is E equal to y minus yk. Now whatever the assumption you have verified on epsilon, this is the residual containing the n observation. Verify on the same. Residuals are independent or not, residuals are normally distributed or not, residuals having a constant variance or not. The same procedure remains the same what we have discussed in the simple linear regression. Now it is in the same way estimation is the same way you have to go for the F test for a simultaneous testing of parameters. Same way you have to go for the individual testing of parameters, and same way you have to go for the prediction. Only the thing is that you can have a addition of a more regression rather than the one regression. But the problem is here. Suppose you say that this epsilon has not, variance of epsilon is not sigma square identity. Identity nahi, it is something different. Either in that ki off diagonal value are 0, but diagonal values are not constant. So we say that there is a problem of a heteroscedasticity in the model. We say the problem is a heteroscedasticity. So here we say that the variance of epsilon is sigma square omega, where omega is not identity. It is a matrix. It has a two case. One case is that the diagonal values are sigma 1, sigma 2, sigma n. Off diagonal are 0. Second is that it has a diagonal values are 1, that is the sigma square, because sigma square is outside. Off diagonal are non-zero. So in the first case, when the diagonal values are different, it means that variance is not constant. So this model is said to be a heteroscedastic model. And whenever you have a heteroscedastic model is there, how to obtain the estimate of parameter? You cannot use the ordinary least square method. You have to go for the weighted least square or generalized least square. You have to use weighted least square or generalized least square. So why? So there are if you are using the OLS, you are losing the efficiency, and that is how one has to go for the weighted least square. Now second part, I say that the diagonal values of variance of epsilon is constant. So they are homoscedastic, but off diagonal are non-zero. It means that errors are independently distributed. And when the errors are independently distributed, errors are not independent, it means there is a presence of autocorrelation in your model. So when your data having autocorrelation, when the errors or disturbance are correlated, because errors itself is a one variable and errors are within correlated with each other, so we say that it is a autocorrelation, self-correlation, autocorrelation. So whenever you are developing the models in a multiple linear regression, you can have these two problems, heteroscedasticity as well as the autocorrelation. If it is a problem of autocorrelation, you have to apply some remedial measures to first detect the autocorrelation, and then you have to have a remedial measures to remove the autocorrelation, and then you can. So that is how we say that in time series we apply the filter or transformation. So this filter or transformations are nothing but they are remedial measures to control the autocorrelation. Now there is a third problem with this. Suppose we say that in a multiple linear regression x1, x2, xk are independent, but here they are correlated. Then there is a problem of a multicollinearity. So when the regressions are correlated, there is a problem of multicollinearity. And when multicollinearity is there, this is not invertible. And if it is not invertible, you cannot get the unique estimate of a beta. But our basic idea is that I am looking for the unique. So first you have to detect how to detect the multicollinearity in my data or not. Second one is if multicollinearity is present, what will happen to my OLS or least square estimator, because already we are using the least square estimate. So what happened to that? If it is a problematic, then how to handle the multicollinearity? So one of the problem of handling multicollinearity, you are knowing that you can apply the principal component regression and ridge estimation. Both are the mathematical method to take care of problem of a multicollinearity. So in that way, we can talk about the multiple linear regression. In the next session, we will talk about how to deal with the autocorrelation, how to identify whether the autocorrelation is present or absent, how to apply the remedial measures. Similarly, next session we will also discuss about the multicollinearity, how to detect